Today we're going to be looking at equations with variables on both sides. We have our helper with us. Hi, I'm going to help you. Okay, I don't know that you'll need much help. We're going to put her off to the side. I'll be watching you. Every so often she'll come in and then she'll leave, just to help. Okay, so equations with variables on both sides. That means that when we combine our like terms, sometimes we will have to combine over the equal sign. Remember, the equal sign is like that Berlin Wall. You know, you've got to do something to get from one side to the other. So, and if we do something to one side, we have to do the same thing to the other side. Otherwise, it's not going to be able to cross that barrier. Okay, so let's just start quite simply with negative 6d. Negative 6d being equal to d plus 4. d plus 4. Okay, now the first thing that you have to determine is where do you want to put things. In this case, we have a single variable term here, okay, a monomial, if you will, with a variable, okay? Here you have two terms. You've got a variable term and you've got a constant. Now, if I move the negative 6d to the right-hand side of the problem, I am literally leaving nothing on the left, which would mean I would have to put a 0 there and then move something else. So we're going to move the variable, okay? So we're going to go ahead and subtract that d, that 1d. We're going to subtract it from this side. And we're going to recognize the fact that even though it does not have a coefficient, we know that that's a 1, okay? So negative 6d minus another d gives us negative 7d equal to, and we're bringing our 4 down. Now, all we have to do is complete the problem by dividing both sides by a negative 7, and that gives us d equals negative 4 over 7. And before you look at that and say, oh, let me turn that into a decimal, my helper is going to say, no! Okay, stop it. This is a beautiful fraction. You may leave it as a fraction. It is not going to be a beautiful decimal. Why? Because as my assistant will point out, see this 7 here in the denominator? You're going to have a very ugly decimal. So don't do it. Just appreciate the beauty of your fraction and just say, I'm done. Okay, thank you, helper. Okay, now let's look at a different type of problem that we might have because they do like to do a little bit of geometry. Let's say we take two lines that are intersecting, okay? And our intersecting lines will create vertical angles. These two angles are vertical. These two angles are vertical. Vertical angles, as we have learned before, are angles that are created by two intersecting lines that are opposite one another. So we've got 7k minus 4 degrees up here and 5k plus 6 degrees down here. Now, because these are vertical angles, we know that they are congruent angles. So that means that 7k minus 4 must equal 5k plus 6 because this angle equals this angle, okay? So now I have to solve. I always put variables to the left. This is not a requirement, okay? But that's the way I'm going to do my problems. You do not have to do them that way. the first thing I am going to do then is move my variable term. So I am moving my 5k over, and notice I'm going to do multiple steps because for me that's easier. So this gives me 2k minus 4 equals 6. Here I'm going to add 4 to both sides, okay, giving me 2k equals 10. Now I am going to go ahead and flip my page because I do like neat work. So 2k equals 10 is where we will start here. Let me just go up to the top. So we're at 2k equals 10, and all we have to do is divide both sides by 2, leaving us with k equals 5. Now, what I have solved here is for k. There's also a second element to that question, okay? And the second question could be, what is the degree measure of the angle, or the angles, because they would both have the same measure. So we can go back and we have, we can either do 7k minus 4, or we can do 5k plus 16, or we could do both. 7k minus 4, 7 times 5 minus 4 is equal to 35 minus 4, which equals 31 degrees. If we did it with the second expression, we would have 5 times 5 plus 16, and this equals, well, it looks like I've got a little problem here. 5 times 5 plus 16, 7k minus 4, 35 minus 4, 31, 25 plus 16. Well, I'm awfully glad that I'm checking both, because it's appearing like I've made a mistake somewhere, because this is 41 degrees, or I'm making a mistake here. So let's re-look at what we did. I think I changed something that I shouldn't have. Ah, I see my mistake. Let's go back. Isn't it wonderful to check your work? Notice here I have a 6. This should have been 16, and I made the mistake here, so that's why I continued it incorrectly throughout. So let's kind of make those changes. 16 plus 4, this is going to be actually 20. Okay, now we're coming back. The joy of checking your work, okay, is just so important. So this is actually 20 here, which means k is equal to 10. Okay, so now let's see if my problems work out better this way. So 7k minus 4, that is 7 times 10 minus 4 equals 70 minus 4, which is equal to 66 degrees, or we have 5k plus 16, 5 times 10 plus 16 is equal to 50, plus 16 equals 66. So beautiful in how we can check our work and make sure that everything has gone the way it is supposed to. Hopefully you are in the habit of checking your work. Now let's talk about our special cases. Okay, let's go ahead and get a clean piece of paper here. Boy, I can't believe my helper didn't find me on that. Okay, really, helper? Really? Really? Okay, so here we are going to look at two different types of problems. So let's say we've got 9 plus 5n equals 5n minus 1. Okay? Now, depending on how you want to do this, let's say we just go ahead and decide to move the variable term first. What is going to happen is on both sides, this is going to zero out. So we're left with 9 equals negative 1. You know what? 9 doesn't equal negative 1. So in problems like this, these are called no solution. Okay? So look for problems that may have no solution. And remember, I'm going to write this down. Remember that 0 is a solution. You're going to have problems that, your variable might equal 0. Well, guess what? 0 is a solution. Okay, thank you, helper. Okay, so next we're going to look at a problem. 9 plus 5x equals 7x plus 9 minus 2x. So the first thing I'm going to do is on my right-hand side, I've got two variable terms that I'm going to combine. So that'll give me 9 plus 5x, and 7x minus 2x is 5x plus 9. Hopefully you can see that with the commutative property, of addition, that these are exactly the same. In cases like this, this is called identity. Identity says that no matter what I put in for that variable, both sides will always work. So any number will work in this equation. So those are called identity. So you can have no solution, you can have identity, or you can have an actual solution. Okay, so that's it. My helper and I thank you for your time, and hopefully the problems will go well.